This is AP practice questions, application time, and my name is James, and welcome back for those people who have been listening to my lectures, and hello, and it's a new kind of introduction, I guess, for those people who haven't met me yet. But right now you're the lucky one because I am giving you a lot of lectures and some kind of tips for you to solve this type of question. And for those people who have been listening to me, you already might have guessed that I'm not really into slow explanation of things. I'm really fast. So if you have to pause, just pause it, right? But if you don't have to, just follow with me, because this is a normal speed that you have to do on your own whenever you are getting into a testing center. At the same time, I looked at Princeton, I looked at Barron's, I looked at Kaplan, and as I looked at it, Barron's is the hardest, I guess, and Kaplan is the easiest. Princeton is kind of normal to the levels, and I prepared 1998 AP, and 1997 AP, and probably 1993, and I think it is quite enough for you to get the gist of this AB test and prepare yourself for AB to get 5 out of 5. And I think it is enough for me to just cover those 3 practice tests. It's not practice test, it's the real test, and if we do that, because I have seen that over 15 years, it hasn't really changed any format of those, except it's getting easier and easier and easier, right? So I want you to feel relaxed and just follow with me, and I'm gonna talk about those differential calculus and integral calculus, what kinds of concepts this test actually involves. So I'm going to talk about those things, and I might introduce some of my lectures or some of the things that I already talked. So just remind that fact. So let's get started. All right, let's go to the board and let's start with number 1. Number 1. What is the x-coordinate of the point of inflection on the graph of y is equal to blah, 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 blah. So this question asks you whether you understand the analysis of f double prime, right? First, let's get f prime first. So what is f prime? In this case, 3, so x squared, right, plus 10x, and 10x, and we can get double prime, which is equal to 2x plus 10. So we want to know when the sign of this double prime is changing. That means that inflection points actually exist when the graph of this thing is actually changing. And let's draw that, right? So this must be 10, and that must be -5. And the sign of this thing, a sign of this f double prime here is positive, and here it's negative. So at this point it becomes 0, right? And this is the point where inflection point actually exists, because f double prime, the sign of it changes, right? So you could say the x-coordinate of that point is x is equal to -5. So this is all about differential calculus. So this is D, right? So let's get into number 2 then. All right, number 2. Number 2 actually asks you whether you understand the concept of integral. So this is integral calculus, and whether you understand how to find the net area. So integral from a to b fx dx is equal to the net area from a is equal to a, and a is equal to b. All right, so let's get this -1 and 4 fx dx. Right, first we can get this. Do we call trapezoid? I don't know whether we call this trapezoid, but this is the area of this thing is equal to what? Equal to, well, this triangle happens to be 1, and this rectangle happens to be 1 times 2, which is 2, right? And this triangle happens to be exactly same as this one. So the area of this trapezoid, I guess this weird shape of geometry, I guess it's just 4, right? And what about this another trapezoid that we have to get? So first we can get this rectangle, right? Not rectangle, but triangle. What is the area of that triangle? Well, if you look at it, the base and height is 1 and 1. So 1/2 must be this area, right? And what about this rectangle or square in this case? This is just equal to 1. But as I said, the integral is the concept-wise, it is net area. And if you are interested in this, just take my APBC calculus, which is part 1, I guess. And net area in this case is that, which is equal to 4 minus 1 over 2 minus 1. So 3 minus 1 over 2, which is equal to 2.5. So this is the answer, I guess. So B is the answer. All right, number 3. So again, integral calculus, but do you understand how to find an antiderivative? So number 3 asks you whether you understand antiderivative. And this was dealt in APBC part 1 of my lecture, which was probably lecture 7 or lecture 6, I guess. So if you are curious about this thing and if you don't understand this thing, just take that course out of curiosity. And all right, so 2 and 1 over x squared dx. So we could rewrite this thing, how? X to the powers of negative 2 dx, right? And as you can see, this is not equal to negative 1, which we could use some polynomial antiderivative. So that is equal to negative 1 times 1 over x, which is we write down bar if you understand. And if you are familiar with this bar, you must have taken my lecture, I guess, because I was talking about this thing, right? So negative 1 over 2 plus 1. Right? And that is equal to 1 over 2. And do we have an answer for that? Yes, we do have an answer, which is C. All right, let's get into number 4. Number 4, it asks you, well, if you read this question, f is continuous and differentiable, which you already have to understand. Or if you are not familiar with this, take my conceptual lectures for differential calculus, but if not, you're fine, right? So A actually asks you about what? A asks you about mean value theorem, right? MVT. What is B asking you? Well, B is asking you about, well, it's same about mean value theorem, but let's see whether it is whether it is true or not, right? Well, f prime of C is equal to 0 for some C such that A is, well, smaller than C and B is bigger than C. Well, we don't know anything about this thing, right? How so? Well, let's talk about y is equal to 2x. What is y prime, which is f prime, right? F prime is equal to 2. And for any point f prime of x is equal to 2. And this actually contradicts what B is saying, right? So B is wrong. And C is right if you understand the derivative, differential calculus. And D is right as well. And what about E? Well, E is that, you know, E asks you whether you understand the differentiability and continuity. So if it is continuous, so what it says, if it is continuous, it is differential, it is integrable. So this was dealt in part 1 of my BC lecture. So if you are still unfamiliar with this thing, just take it for getting a harder concept of this thing. Because if you didn't understand what continuity means and what integrability means, then you're at loss right now. All right. So number 4 was, well, B was wrong. So B was the answer for that because we're finding which option was false. And let's get into number 5. All right, number 5. Number 5 asks you whether you do understand antiderivative of a trigonometric form. So it is asking you to find antiderivative of this thing, right? Well, this is usually connected to fundamental theorem of calculus, and